Welcome to Basics of Real Analysis, Unit 1. Let us have a glance about our syllabus. So, in Basics of Real Analysis, the first unit is Basic Topology, and we have to complete the course with the kinds of sets, finite, countable, uncountable, open sets, closed sets, etc. So, let us start with Unit 1, Basic Topology. So, and that's our agenda. So here in this unit, we define some topological properties of the real numbers and its subsets. So be clear with what is called real number system. So let us start with the first interesting concept, open set. So consider an open set G in R. If for every x in G, there exists a delta greater than 0 such that G contains x minus delta, comma x plus delta, then we call the set G to be open. So here we are having a piece of segment around the element x which lies totally inside the set G. So it should be true for each and every element of G. So whatever element you take from G, it should contain a piece of segment around it which is totally lying inside, that is completely lying inside the set G. So this is the condition for a set G being open. Okay, so be clear with the concepts. Whatever element x in G, it should contain a piece of segment with radius delta that is completely lying inside G. Okay, then we call the set G to be open. So now let us have an example. So the segment 0, 1 is open. So you consider any element x in between 0 and 1. So be careful, in between 0 and 1. So x cannot be 0 and x cannot be 1 because the segment 0, 1 does not contain the elements 0 and 1. So whatever element you take in between 0 and 1, say x, then you can find delta small as much as possible so that the segment x minus delta, x plus delta completely lying inside 0, 1. So the set 0, 1 is open. Okay. So now you consider the set interval 0, 1. So when you have an open brackets on both sides, we call the set to be segment according to Rudin. And if you have box brackets, we call the set as an interval. So this notation is about is according to Rudin. So consider the set 0, 1. Now consider an element x between 0 and 1. Then as an example 1, we can find piece of segment x minus delta, x plus delta that completely lying inside the interval 0, 1. That's fine. Okay. Now come to the endpoints. Consider an element 0. So if you take 0, whatever delta, that is positive delta you take, the segment minus delta, plus delta, that is actually 0 minus delta, 0 plus delta. So it's not completely lying inside the interval because minus delta, 0 is just lying outside the set. So it is not open. And the same case follows for the endpoint 1. So here 1, 1 plus delta does not contained in the set. So the two elements 0 and 1 do not satisfy the conditions given in the definition. So the interval 0, 1 is not open here. Okay. So be thorough with the definitions. Each and every symbol is very, very important. And constructing example is also very, very important. So if you are able to construct your own example, then it shows that you understood the concept very well. So you have to feel free to feel free to make this open discussion for questions or clarifications before proceeding on to next sessions. Okay. So if you're really thorough with the concepts, then try to give some examples of open sets in R. Let us discuss your answers in the discussion forum. Okay, so this is for today's session. Let us meet in the next session. Till then, take care. Bye bye.